Good day, guys. Let me introduce myself. I am the greatest teacher there is, the greatest teacher there was, and the greatest teacher there ever will be. Now, the topic for today is Laplace transform. You might be wondering, what are Laplace transforms? What is this? They just taught it to us in school, and you don't even know what it's all about. You just know that there's a topic named Laplace transform, and there's a whole bunch of math going on the board. I'm here to explain what it's about. Now, Laplace transform is just an easier way of solving differentiation. So you use Laplace transform in applications like robotics, in electrical circuits, and stuff like that. But I'm not here to tell you about that because I know you just want to pass your exam. You don't actually care, you don't want to know, you just want to pass your exam. So let's move forward. Now, this is the formula for Laplace transform. This is the basic formula for Laplace transform. And if you understand it, you understand Laplace transform. So what is that formula? Laplace transform of f of t. Anything we want to take its Laplace transform of is called f of t. So Laplace transform of f of t is equal to what? Integral, you take the integral of f of t multiplied by e power minus st dt. Do you understand? All you have to do is take integral of what you were given, multiply it by exponential to the power of negative st dt, and that is going to give you your answer. So the final answer is called f of s. That is the answer you get whenever you take the Laplace transform of anything. Do you understand? I know you do. Now let's move forward. Firstly, these are the basic Laplace transforms we have. The basic stuff about Laplace transform. You have to learn how to derive these. You understand? If you learn how to derive these, you perfectly understand everything you need to know about Laplace transform. The first one is A. How to take the Laplace transform of a constant. Now, A can represent things like 3, 4, 5, 6, 100. You get? So let's go. What is the Laplace transform of A? So that is, let's take Laplace transform of A. We are going to, according to the formula, what did it say? Integral to the infinity 0. T is going to be 0, right? Then what is our f of t? A times e to the negative st dt. That is it. That is it. Now all you have to do is to know how to integrate this. Do you understand? Now let's move forward. Now, what are we going to do here? The first thing we do is this. You remove this because you know it's a constant. It's a constant. So this remains here. Now let me ask you, if you take the integral of e to the negative st, what are you going to get? Let me give you 3 seconds to think about that. You failed it. You failed it. Now this is what you're going to get. Anytime you take integral of e to the negative whatever, what you're going to get is this. This is what you're going to get. This is what you're going to get, and you failed it. This is what you're going to get. Now, this is ranging from infinity to 0, and A is still sitting pretty outside, right? A is still sitting pretty outside. So this is negative e power negative st all over s. Now see what happened here. See what happened here. Since we are integrating it with respect to t, we are taking the integral of this dt. That is, we are integrating with respect to t. So what happens? S is going to come down. Whatever we have here is going to come down. What actually came in, not just s, is negative s. It came down, right? So when negative s came down, we now have negative e power, same thing, same powers. Nothing happens to the power, it still stays up there, but whatever is beside t is going to come down. Do you understand? So that is why negative s came down, and then everything became negative and s is now down. Do you understand? Now, it still falls within the boundary of infinity and 0, right? So what is our next step? Our next step is this. We bring out negative and s. So we have negative a over s into e power minus st infinity and 0. Do we understand? Do we understand? Do we understand? So now, what are we going to do from here? I need my duster. Oh God, where's my duster? What the heck? I can't find it. Whatever. I hope you're following. So now what I'm going to do is this. Infinity e power minus st, where t is infinity. What are you going to get? E power infinity. What do you have? E power infinity. What do you have? You don't know the answer. You failed it. E power infinity is 0. E power infinity is 0. Note this. E power negative infinity is what? What's the answer? What's the answer? You failed it. It's infinity. E power negative infinity is infinity. E power infinity is 0. And e power 0 is 1. Because anything raised to power 0 is 1. So now let's move on. Let's move on. So if we take this e power minus st, where and then we minus it from this, multiplying negative s to infinity is still infinity, right? So e power infinity, like we said, is going to give us 0. So we are going to have now e power negative st all power 0 is going to give us what? You got it, 1, because that one is simple. 1. So yeah. So what do we have now? At last we have negative a over s all over negative 1. So we have this. Negative a over s multiplied by negative 1 is what? You got it, because it's simple. So we have a over s is our final answer. That's our final answer for this question. So when you have what is the Laplace transform of a of any constant, the answer is going to be that constant over s. A over s is the answer. So if someone gives you what is the Laplace transform of 3, the answer is 3 over s. What is the Laplace transform of 100? The answer is 100 over s. Now, what if they give you something like what is the Laplace transform of exponential power negative 1 random constant multiplied by t? Now we are going to continue tomorrow. It's already getting dark. This is my first time teaching on this platform, and I can still confidently say that I'm the greatest teacher there is, the greatest teacher there was, and the greatest teacher there ever will be. Stay tuned and we'll continue tomorrow.